So in this video we're going to talk about interpreting graphs of linear and nonlinear functions. So in this first part over here we see that we have a parabola that is pointing in the negative direction, and it has an apex at 4 and 4, 2. So let's take a look and see what this means. Alright, so this is a graph. Now a parabola is not linear, because that would be a straight line with a slope. That would be the y equals mx format. And it's not constant. A constant would be something like y equals 5 or x equals negative 2. Something without a slope that's just a straight line up or down or across. So this is a nonlinear function. And the y-intercept of this graph, so y-intercept means what's the y value when x equals 0. So the x-axis right here in the middle is where x equals 0, and we go down and this function intercepts the y-axis at negative 6. Okay, and the x-intercepts of the graph. Now there are two of these because a parabola, well, you can see what a parabola is. It's a squared function. This one is a negative value that's squared. So it has two values. Okay, so the x-intercepts, so when y equals 0, what does x equal? So y equals 0, and x equals 2 and 6. So we have 2 and 6 for the x-intercepts. Now the greatest value of y, so that's going to be at the apex over here, at least if it's a negative value, or if it's a negative parabola. So we find that at 4, when x equals 4, is going to be right in the middle of the parabola. And so when x equals 4, y equals 2. So 2 is the highest point on this curve, which is usually what we call a function that's not linear, so it's a curve. And you can see why it's curved. Okay, so the greatest value is 2, and it occurs when x equals 4. Alright, so for x between 2 and x between 6, the function of the value is, how's it related to 0? So we see between 2 and 6, that's when, those are the x-intercepts if you recall. And so everything in between there is going to be positive. So all these values are positive. And so if they're positive, then they are greater than or equal to, because we see that the x can equal 2 and it can equal 6, and it's 0 at these. So it's equal to or greater than or equal to 0. And is that all it asks for? I believe so. Alright, so let's look at this graph. So we have another parabola pointing in the negative direction, and it has an apex at 1.5 and 11. Alright, let's check this out. So the graph, nonlinear, it's a curve, it's a parabola, and the hang time of the football, I guess we should read this problem. Okay, so the hang time is the amount of time it's in the air after it's been kicked. And Zara kicks a football. The height in meters is 11 meters. And the football above the ground. Okay, so the x-axis is the time that it's in the air. So this is basically a position function. Okay, well, it is a position function where it has the value that it's in the air versus the time that it's in the air. Alright, so the hang time, that's going to be all the values where it's in the air. So it's in the air between t equals 0 and t equals 3. So that means it's in the air for 3 seconds. And the football reaches its maximum height when t equals, alright, so here's the maximum height, 11, and it reaches that height when it's at 1.5 seconds. And it might be a little beyond this course, but anytime that just gravity is affecting an object, you're always going to find the maximum height halfway between the time it's in the air. Alright, so 1.5. Alright, the maximum height is, well, 11 meters. We already went over that. And for t equals 0 and t equals 1.5, the height is increasing. Alright, we see here, and you can see that it's increasing because the values are going up, so they're increasing. And then as soon as they reach this 1.5, it's instantaneously not moving up or down. It's instantaneously at 0. And then everything after that is going down. Okay, so this graph right here, we see that this is a straight line. So it's, oh, it doesn't ask that. Okay, I guess we should probably pay attention. Alright, Jimmy sells more hot dogs, his profits will increase. Alright, let's take a look and see what this is saying. Alright, so Jimmy's selling hot dogs at this football game. He bought hot dogs, buns, condiments, trying to make a profit. Graphs the profit he will make as the number of hot dogs sold. Okay, so if we're looking at that, this end value, that is the amount of hot dogs that he sells, and this P is the profit. So if we're looking at this graph, we see here that if he sells 8 hot dogs, he'll break even with how much he spent. So he spends money just to get all the ingredients. So he buys hot dogs and buns and condiments and all that stuff. So he spends $8 to do that, it looks like. And so he won't make that money back until he sells 8 hot dogs, because it looks like he's selling them for $1 a piece, because the slope of here is 1. Okay, so that's what this is saying. So every hot dog that he sells after 8, it will increase his profit by 1. Alright, so if he sells more hot dogs, his profit will increase. And then Jimmy sells the hot dogs, we already talked about that, for $1 a piece. And if you want to talk about that more, you can look at this slope right here. So you see that every time n increases 1, so every time he sells 1 hot dog, his profit goes up 1. So that's a basic, rise over run slope problem, but that's essentially why that equals $1. Alright, so Jimmy needs to sell, we already talked about this as well, so he sells 8 hot dogs to recover the money he invested. If Jimmy sells $15, 15 hot dogs, so at 15 his profit will be 7. Oh, I guess that already answers, okay. Then you can do that by looking at the graph, 15, and then the y value equals, or the p value equals 7, or you can also, keep in mind that every hot dog he sells is another $1, and the first 8 is when he breaks even, so 15 minus 8 is 7. So you can do it mathematically or by looking at the graph. Alright, to make $12 in profit, you can do this the same way. You can do, well, $8 is breaking even, so it'd have to sell how many hot dogs to make $12. So 8 plus 12 is 20. So if you're looking, you can do it mathematically over here, and you can see that at 20 it equals 12. Of course, if you're solving it graphically, then you would look at the 12 for profit, go over here and see where it intercepts, where it meets the line, and then look down here and say, okay, so that's 20 hot dogs. Alright, so hopefully that video helps. If you need extra help, just let me know.